Here we have a SAT math question. Okay, let's go with the information. Here we have a triangle. In the figure above, angle measure BAC equals to 30 degree, angle measure BCA equals to 45 degree, and AB equals to 8. What is the length of BC? So we have to find the length of this side of the triangle, that is BC over here. Okay, in my first step, what I'm going to do is I'm going to draw a perpendicular line from the vertex B to the side AC of the triangle. And also, I assume the perpendicular line meets the line segment AC at the point D. So since the BD is perpendicular to AC, here we have a right angle that is 90 degree, and here also we have a right angle 90 degree. Okay, now let me consider the right triangle ABD over here. In this right triangle ABD, we know the interior angle measure over here is 30 degree, and here we have 90 degree. Then what must be the measure of for this interior angle over here? In any triangle, the three interior angle measures will add up to 180 degree. We know that this is 30 degree and this is 90 degree, and it must be 60 degree. So that these three interior angle measures will add up to 180 degree. Now we got a special right triangle, that is 30, 60, 90 special right triangle, that is ABD over here. In a 30, 60, 90 special right triangle, the side which is opposite to the smallest angle measure 30 degree is the shortest leg. So BD is the side which is opposite to the smallest angle measure 30 degree. So this is the shortest leg of this right triangle BD. Always we assume X as the length of the shortest leg of 30, 60, 90 special right triangle. The next longer leg is AD, which is opposite to 60 degree angle measure. Now to get the length of this side, leg AD, what we have to do is we have to multiply the length of the shortest leg X by square root of 3. So the length of the leg AD is X times square root of 3. And the longest side of the triangle is AB, which is hypotenuse, and also it is opposite to 90 degree angle measure, right angle. Okay, now to get the length of the hypotenuse, what we have to do is we have to multiply the length of the shortest leg X by 2, that is 2X represents the length of the hypotenuse AB over here. Okay, already we know the length of the hypotenuse, that is 8, it's given in the question itself, but we got it 2x. So this 2x and 8, both of them represent the length of the hypotenuse, so they must be equal, that is 2x equals to 8. Now to solve for x, we have to divide both sides by 2. When I do so, this 2 will cancel out, then x equals to, when I divide 8 by 2, I am getting 4. Now I got the value of x, now we can replace this x by 4. Okay, let me write it over here, and also let me erase the other stuff in this triangle. Okay, now let me consider another right triangle that is over here, that is BCD. In this right triangle, the interior angle measure over here is 45 degree, and here we have a right angle, so it measures 90 degree. Then what must be the measure of the angle measure over here? It has to be 45 degree. So that the three interior angle measures, this one, and the right angle over here will add up to 180 degree. Okay, and also this BCD is also a special right triangle, that is 45, 45, 90 special right triangle, and also it is isosceles right triangle because two interior angle measures are equal. In an isosceles right triangle or in any isosceles triangle, the sides which are opposite to equal angle measures must be equal in length. So the side BD is opposite to the interior angle measure 45 degree, and it is having length 4. And the side CD is also is opposite to the same interior angle measure 45 degree. Since the length of BD is 4, the length of CD also must be 4, because of both the sides BD and CD are opposite to the same angle measure 45 degree, so they must be equal in length. In a 45, 45, 90 special right triangle, usually we assume x as the length of each of the two equal sides. So for the side BD and CD, we assume x as the length. In that case, the length of the hypotenuse BC is this x times square root of 2. Already we know the length of the side BD and CD, that is 4, that is instead of x we have 4. So to get the length of the hypotenuse BC, what I have to do is I have to plug in x equals to 4 over here. In that case, I am getting 4 times square root of 2. Therefore, the length of the line segment BC is 4 times square root of 2, and we find this 4 times square root of 2 in answer choice B. The correct answer choice for this question is B.